In this video, I want to explore the relation between the derivative of a function and the derivative of its inverse. I want to answer this question. If a function is differentiable and it has an inverse, must the inverse function also be differentiable? In other words, if f has a derivative, must f inverse have a derivative as well? Moreover, can I write f inverse prime in terms of f prime? To the first question, the answer is not necessarily, unless we add an extra condition. I can explain geometrically. Consider as an example the function f described by this graph in blue. This function is differentiable. It has a derivative everywhere. It is also one-to-one and it has an inverse. As you know, we can obtain the graph of its inverse by reflecting the graph of f with respect to the diagonal of the first and third quadrants. Here is the graph of the inverse in red. Now, if the graph in blue has a well-defined tangent line at every point, then the graph in red, which is a reflection, will also have a well-defined tangent line at every point. So f inverse should be differentiable everywhere, right? Not quite. Consider the point I am labeling P in the graph of f. At that point, the tangent line is horizontal and the derivative is 0. I am labeling Q the corresponding point for the inverse. Think about what happens when we reflect a horizontal tangent line. F inverse must have a vertical tangent line at Q, with infinite slope, and thus F inverse is not differentiable at Q. Therefore, it is possible for f to have a derivative while f inverse doesn't, but this is the only thing that may go wrong. We get a nice theorem. Consider a function f defined on an interval I. If f has an inverse, f is differentiable, and the derivative f prime is never 0, then we can conclude that f inverse is also differentiable. Side note, this little result should not be confused with its big brother, so to speak. There is another theorem called the inverse function theorem. The inverse function theorem is much more complicated and much more important as well. It belongs in a multivariable calculus course, so it is beyond the scope of this sequence of videos. But just in case you have heard of the inverse function theorem, that is not what I am talking about. The little result I am presenting here is much less ambitious. Back to what I was doing. Once we know that both f and f inverse are differentiable, how can I write the derivative of f inverse in terms of the derivative of f? We already know a relation between f and f inverse. F of f inverse of y equals y for all y in some interval. I am being careless with domains. Then, if I take the derivative of both sides, I will get a relation between the derivative of f and the derivative of f inverse. Let's do that. The derivative of the left equals the derivative of the right. On the left, I need to use the chain rule. I get the derivative of f at f inverse of y times the derivative of f inverse at y. And on the right, I simply get 1. This is promising, but this equation looks more complicated than it actually is. I can make it look nicer. If I call f inverse of y x, or equivalently I set y to be f of x, then the equation says that the derivative of f at x times the derivative of f inverse at y is 1. And from here I can solve. F inverse prime is 1 over f prime. I just have to remember that f and f inverse are evaluated at different points. And that's the equation I was looking for.